Okay, so this is 7-6 and we're looking at linear programming. Now the math skills that we need for this section are really just the same thing we were doing in 7-5, but it's asking us to find maximum and minimum values of these functions. So there's a couple terms that we need to know. The whole concept we're talking about is called linear programming, and we're just, again, looking at maximizing or minimizing certain factors. Now, the objective function is, for example, this right here. It's what we're trying to maximize or minimize. And these right here would be called our constraints. Those are the constraints on our objective function. So we're going to go ahead and solve this problem here. We only have one example. And let's go ahead and graph some of these. I'm going to start setting up my graph here. I think I'm going to zoom out so we can get everything in here. And let's go a little further. Okay, so I'm setting up my graph here. And we're going to go ahead and just start graphing. So my first equation, I have x greater than 0 and y greater than 0. I'm going to do this one in blue. So that would be a solid line here and a solid line here. I'm going to make them just a little bit darker so we can see exactly where they are. And we're saying greater than 0 and greater than 0, so we're really just looking at this first quadrant right here. Okay. The next one, I can rewrite that if I want to as y is less than or equal to negative 2x plus 8. So my y-intercept would be up here at 8, and then my slope is negative 2. Again, it's really, really important that we have detailed graphs here. This is a solid line here. And we'd be shading down. Okay. So for now, just to keep track of the shading, I'm on this side of the line, I'm on this side of this line, and I am below the green line. Okay, and then we've only got one left, that last one. We'll do that one in red. And that line we can solve, and we get y is less than or equal to negative 2 over 3x plus 4. So my y-intercept, my slope is negative 2/3. Again, so important that we can see exactly where those points cross. This is also a solid line. And we're shading down. So our overlapping area then would be this kind of strange shape here. So far we've been doing the exact same thing as 7-5, and we're about to see how things change a little bit for this section. We need to see exactly where these vertices are. So this point is 3, 2. This point is 0, 0. This point right here is 4, 0. And this one is 0, 4. Now we need all of those vertices, and I'm going to list them up here. And we're plugging them into that objective function. Now we're looking for the maximum value. So when I plug these values in, I want to get the biggest number possible. So z is equal to 2 times 0 plus 3 times 0 equals 0. Probably not the biggest one. Two times 0 is 0, plus 3 times 4 is 12. So that's at least bigger. 2 times 4 plus 3 times 0, that gives us 8. So that's not our maximum. Right now 12 is our maximum. And let's see, 2 times 3 plus 3 times 2, that also gives us 12. So what's interesting about this example is we have two maximums. Now what this is telling us is that our maximum occurs at 0, 4, and 3, 2, and our maximum value is 12. And that's what we're doing with objective functions. You could have a similar problem where it asks for the smallest value. If this equation had asked for the smallest value, then 0, 0 would have been our answer. And that's the end of this section.